In this lab, we're going to separate 3 different chemicals so that it's easier to visualize. I have the chemicals represented with a mermaid, a cube, and a rocket. The 3 different chemicals have different properties that we're going to use to separate them. This rocket right here, just like in real life, we're going to make it fly off from the mixture. The mermaid, not like in real life, but we're going to say the mermaid likes the water and is going to swim off in the water. The cube is just going to sit there and it won't dissolve in the water, so we can pour water off around it. The lab wants you to figure out the percentage by mass of each of the 3 items in the mixture. The math is very simple. We're just figuring out percentages. We want the percentage of the mixture that each part is. So if, for example, we figure out that 2 grams left the mixture, that's how much would have been the rocket. It's 2 grams divided by 5 grams times 100%. So we're going to know, once we do the math, what percentage that the rocket was. What makes it difficult to separate chemicals is because they do not look like 3 completely separate things to our eyes. So we'll just pretend a magician came along and turned those 3 items into random little dots, which is what it would look like in the lab. But those random dots still retain those properties, as in the rocket can fly off, the mermaid can swim away, and the cube will just sit there. So you take the container of unknowns and you put it in a container you can use to weigh the mass of the mixture. Once you have that mass recorded, you're going to start the process of separation. You're going to start by heating the beaker that contains the mixture. In lab, you have to be patient and wait several minutes. But as it begins to heat, one of the particles, or actually several of the particles, will begin to leave the beaker. So sometimes they'll go really near to the side of the beaker and they'll get stuck. That's because the higher section of the beaker isn't as hot as the bottom, it's a little bit cooler. What's really happening is that this compound is changing into 2 things that are gases. When this happens, you make NH3 as a gas and HCl as a gas. That's when you heat up this compound. So those 2 gases will leave, and you're effectively removing that whole NH4Cl compound. But it's reversible, so if it gets to a point where it starts to cool down and 2 molecules run into each other, they'll reform NH4Cl. That's what ends up stuck in the upper section of the beaker. This is not a problem at all because it's stuck very, very firmly and we can pour the mixture out around it. So what has just happened is that our rocket has left the beaker, or there's a tiny bit of rocket stuck on the upper section of the beaker. Now we have 2 remaining things. We still need to separate them, but we have to get them to cool first. Let's move the remaining compounds into another beaker that's cooler. We'll let the whole thing cool and we'll get the mass. Once we get this mass, we'll know how many rockets left. This is because we know the mass of the whole mixture to begin with. So we take the 5 grams of the mixture, you just subtract and you find out that there was 0.5 grams of rocket in the mixture. And it's very easy to figure out the mass percent at that point. 0.5 divided by 5 times 100. Now we need to separate the remaining 2 compounds in the mixture. So let's take another beaker. We'll pour them in the beaker. We're going to add water. That's because we know that the mermaid likes water, and we want the mermaid to swim away and separate from the block, the cube. So look at our mermaid. It's swimming around. It's getting in the water and dissolving in the water. We know that the cube won't dissolve, so we're going to take the water with our mermaid and we're going to pour it into another container. The cube is still a little bit wet because it had water touching it, so we need to let it dry in the oven. We're going to put it on a watch glass. You'll see it in a watch glass in the oven. After it has dried and cooled from being in the oven, we'll get the mass of this. We'll say something like it's 3.0 grams. At this point, it's really easy to figure out the percentage because it's just the 3 grams divided by the 5 grams times 100%. Let's go on and look at what's going on over there with our mermaid in the water. You may have noticed our mermaid's in the water, but we still have to separate 2 things. We have water we need to separate from the mermaid to get the mass. So we're going to heat. We know our water, of course, will boil off. And after all of the water boils off and we watch for splashing, it's really easy at the end of this one to have a little bit of flaking upwards. And so we're going to heat it in the oven. This is after we've gotten almost all of the water off of it. And let's say that we get the mass after it cools to be 0.4 grams. Again, it's very easy to figure out the percentage of mermaids in the mixture. It's just the 0.4 grams divided by 5 grams times 100%. Now, of course, your numbers will be different, but as a reminder, you will have 3 percentages at the end of the lab. The compound that we're saying is the rocket would be 0.5 divided by 5 times 100%. The compound that we've been calling the cube or the metal piece, it's 3 divided by 5 times 100%. And the compound that we've been saying is the mermaid is 0.4 divided by 5 times 100%. Be sure to pay attention to your significant figures. In this lab, we only gave examples to 1 decimal place, but our scale has many more decimals. Don't lose any numbers, write every one down. And one last note, in this lab, the techniques that you're seeing are very common chemistry techniques. If you ever work in a lab, you will find yourself having to separate different compounds because most chemical reactions aren't neat and clean, only giving one product. There are more ways to separate compounds, but these are some of the most common that are used in labs everywhere. You'll definitely get more opportunities to separate mixtures when you take organic chemistry next year.